Okay, let's discuss determinants properties. Very important. Okay, first property is determinant of A is equal to determinant of A transpose. Okay, in your examination paper it may be given like this in words: det of A, that is equal to det of A transpose. Okay, second important property, okay, determinant of AB, that is equal to, it should be write as determinant of A into determinant of B. And the third one is determinant of Ka, that is equal to K raised to power of n. If you take K outside, K is any real number, okay, except 0. Okay, except 0. If you take any real number, if you take that real number outside, K raised to power of n into determinant of A, where n is equal to order of the matrix. Okay, this is also important. Okay, next important, fourth one, determinant of adjoint of A, that is equal to determinant of A whole power of n minus 1. This is also very important. Okay, here also n is order of the matrix. Okay, and it can be written like this also. If it is determinant of adjoint of A, it can be written as determinant of A, okay, the same determinant of A power of n minus 1, but here adjoint is repeated 2 times. Okay, you should take whole square here. Okay, in general, if it is determinant of adjoint of and so on, adjoint of A, that is equal to determinant of A power of n minus 1. Okay, but here if it is adjoint is repeated t times, it can be taken power is t here. Okay, this is the important one. And determinant of A power of R, that is equal to determinant of A whole raised to power of R, should you can take. Okay, R can be any integer. Okay, for example, sometimes they will ask in question determinant of, what is determinant of A inverse. They will give determinant of A and they will ask what is the determinant of A inverse. That time you should use this formula, determinant of A whole power of minus 1. Okay, this is the result you should use. This is very important. And one more result, determinant of A plus B is not equal to determinant of A plus determinant of B. Okay, if it is minus also there, they both are not same. Okay, then one more result, determinant of adjoint of K times of A. Okay, if it is, this is the formula, you should observe that. Okay, you know the determinant of adjoint of A formula, that is determinant of A power of n minus 1. Okay, in place of A what is there? Ka. Okay, then you apply first determinant of this formula. Okay, you should apply this fourth formula first. In place of A, Ka is there, Ka whole power of n minus 1. Then after that you apply this formula. Which formula? It's the third formula. If you K is any real number, if you take K outside, K power of n. Okay, and also n minus 1, here one more power is there, n minus 1 whole power of n minus 1, and determinant of A power of n minus 1. Okay, it can be rewrite as K power of n into n minus 1, determinant of A power of n minus 1. This is the formula you should remember. Okay, this is very important. And 10th one, if A is skew-symmetric matrix, if the matrix is skew-symmetric matrix, okay, that means A is equal to A transpose. Okay, if you apply determinant on both side, apply determinant on both side, det on both side, we get det of A is equal to det of A transpose. Okay, we know that det of A is equal to det of A transpose, the both are same, right, by the first formula. Okay, det of A is equal to det of A, that means these two quantities are equal. That means it may be any real number. Like always remember determinant Okay, determinant is just a number. Okay, it is a value. Okay, it is a value, it is a constant value, or it is a number, determinant. Okay, det of a is equal to det of a means it may be any real number. Determinant det of a should be any real number. Okay, any, but means if it is 2, it is also 2. If it is 1 by 2, it is also 1 by 2. That means if your matrix is symmetric matrix, then determinant is any real number, you should remember. Okay, if A is skew-symmetric matrix, skew-symmetric. Okay, if the matrix is skew-symmetric matrix, you know that what is skew-symmetric matrix definition? A is equal to minus A transpose. Okay, if you apply determinant on both sides, det of A is equal to det of minus A transpose. Det of A is equal to minus 1. Okay, if you take minus outside, minus 1 power of n by the property. Okay, if you take real number outside, you should take power n. Okay, determinant of A transpose n is order of the matrix. Okay, determinant of A is equal to minus 1 power of n. Determinant of A transpose by the property, it can be written determinant of A n only. Okay, and there are two cases here. Case 1, if n is equal to even. Okay, n is equal to even means it n is any order 2, 4, 6 like this. Okay, what happens? Determinant of A is equal to minus 1 square determinant of, for example, n is equal to 2, for example, determinant of A is equal to what we get? Determinant of A. That means in this case determinant should be any real number. Determinant should be any real number. Okay, case 2, n is equal to odd. Okay, the odd nothing but it may be 3, okay, 5, 7 like this. Okay, determinant of A is equal to minus 1 power of 3, for example, determinant of A. Determinant of A, if you take any odd number here, you get minus into determinant of A. That means if you take this side, determinant of A plus determinant of A is equal to 0. 2 times of determinant of A is equal to 0. If you divide with 2, determinant of A is equal to 0. Okay, always remember, if order is odd number, determinant of any skew-symmetric matrix is 0. Okay, if order is even number, determinant of skew-symmetric matrix is real number. Okay, this is the property you should remember. And determinant, okay, these are the common properties. Okay, you remember. And adjoint of A is equal to determinant of A power of n minus 2 into A. And determinant okay, this is completed. And adjoint of K, okay, if you take K outside, K power of n minus 1 into adjoint of A. Here determinant of A power of n is equal to determinant. Here n is any integer, you can take any integer. Okay, this is the some important formulas related to matrices and determinants. Okay, now start some problems. Okay, these are some important multiple choice questions. Okay, first we will discuss matrices questions. Okay, the first question is, let A is the 2 by 2 matrix, 2 by 2 square matrix whose elements are given by. Okay, then matrix A is, what is the matrix A? Okay, then first you should consider 2 by 2 matrix, general 2 by 2 matrix. Okay, A11, A12, A21, A22. Okay, this is the general 2 by 2 matrix. What is the condition is given? Aij. Okay, this is the condition is given. Okay, first find A11 in place of I1, in place of J1. If you substitute, you get mod of, in place of I1, 1 square minus 1, that is equal to 1 square is 1 minus 1 is equal to mod of 0. Mod of 0 equal to 0. Okay, next A12. Okay, in place of I1, in place of J2, 1 square minus 2, that is equal to mod of 1 square is 1 minus 2, that is equal to mod of minus 1. Okay, see, in modulus, inside a modulus, if you take any number, it always gives positive. Modulus gives always positive number, that is equal to 1. Okay, then find a21, that is equal to I values 2, j value is 1. Okay, just you compare this with aij. I is 2, j is 1. Okay, substitute these values in given condition. We get mod of 2 square minus 1, that is equal to 2 square is 4 minus 1, that is equal to mod of 3, that is equal to 3. Next find a22. I is 2, j is 2. You get 4 minus 2, that is equal to mod of 2, that is equal to 2. Then if you substitute all these values in matrix a11 value is 0, a12 value is 1, a21 value is 3, next a22 value is 2. Okay, this is the matrix A. Then what is the option? Which option is correct? 0 1 3 2, 0 1 3 2. Then B option is the correct option. Okay, then second question is, if you observe that these two matrices are equal, if any two matrices are equal, then corresponding elements should be equal. Okay, that means same position elements should be equal. Okay, this is the condition. Then if same position elements equal, this is the equations we get. Okay, then you simplify these equations, then plus y minus y. If you eliminate this one, x plus x 2x, okay, that is equal to 2 plus 4 6. Then x value is equal to 6 by 2 equal to 3. X value we get 3. Okay, if you want y value, you substitute any of these equation, you get y value. X equal to 3. If I will substitute in equation number 1, x equal to 3 plus y is equal to 2, 3 plus y is equal to 2, y is equal to 2 minus 3, y is equal to minus 1. Then we want x into y value, then multiply 3 into minus 1, that is minus 3. Then C option is the correct option. Okay, next third question. a12 value is equal to k times of sin x cos x e raised to power of 2x in the matrix A. Okay, 2 by 3 matrix is given, where the condition is aij is equal to e raised to power of 2ix sin jx. Then what is the value of k is they asking. Okay, this is the condition. Then substitute this value a12, that means I is equal to 1, j is equal to 2. Substitute here, we get a12 is equal to e raised to power of 2, I value is 1, that means 2 into 1 2 only, x e raised to power of 2x sin j value is 2, get 2x. That means just compare with this and this. Okay, see, sin x cos x can be written as, see, if you multiply 2 and divide 2, then 2 sin x cos x can be written as sin 2x e raised to power of 2x k by 2. Then compare with this and this. Okay, here this coefficient is 1, then k by 2 value is equal to 1, k is equal to 2. Then option D is the correct option. Okay, then fourth question. If A and B are two matrices such that A plus B is defined, then okay, if these two are matrices, then it is defined. When it is defined, number of columns in A is equal to number of, no, say if sum or difference is defined, only the order of the matrices should be same. Okay, that means D option, A and B must be the same order. Okay, then only A plus B or A minus B defined. Okay, multiplication is defined if number of columns, see, number of columns in A, that is equal to number of rows in B, then multiplication is defined. Okay, product is defined. For this question, D is correct. And the matrix A is which type of matrix? See, first scalar matrix. Okay, if you want to say the matrix is scalar matrix, diagonals elements should be same and remaining elements should be zeros. Okay, here observe that remaining elements are non-zero, okay, not zeros. Okay, that means it is not a scalar matrix. And diagonal matrix, it is not diagonal matrix also, because in diagonal matrix also diagonal elements should be non-zero elements, remaining elements should be zeros. Okay, but in this case also it is non-zero elements, it is also not correct. Unit matrix means identity matrix. Identity matrix is also a diagonal matrix, right? That means all the diagonal elements should be 1, remaining position should be zeros. Okay, but here non-zero element is present, this is also not a unit matrix. Then it is square matrix. Square matrix means number of rows equal to number of columns. Here see 3 rows, okay, 3 columns, okay, 3 rows and 3 columns are equal, then it is a square matrix. Okay, this is little bit advanced question. Okay, 6th one. Okay, they are asking to find A matrix is given, B matrix is given, they are asking to find what is the value of A minus B. Okay, see, if you take A minus B, what is matrix A? Matrix A is what? Sin square x pi, sin square pi x, okay, minus, again here one more minus is there. See, if you take minuses directly, I will take here instead of taking there, I will take here directly. Okay, A minus B. See, A square x pi minus into minus plus, we get first position is sin square x pi plus cos square x pi. Okay, next this is tan x pi, okay, minus tan x pi. Then this we get sin x by pi minus sin x by pi. Okay, then cosecant square x pi minus cot square x pi. Okay, we know that by the trigonometric identity is sin square theta plus cos square theta equal to 1. See, angles are same, then sin square pi x plus cos square pi x, this value equal to 1. Okay, and this is 0, they both are same terms, both are get cancels. This is also same terms, both are get cancels. This is also trigonometric identity, cosecant square theta minus cos square theta, cot square theta equal to 1. That's why this value equal to 1. 1 0 0 1, it is what? It is a 2 by 2 identity matrix. Okay, 2 by 2 identity matrix, that means simply identity matrix, right? It is identity matrix. Okay, then which option is correct? Option A is the correct option. Okay, next 7th question. A, B, these two matrices are given, they are asking to find what is the value of C. Okay, this is the equation, expression is given. Okay, this is the equation is given. Okay, from here find A, C value first. Just send this terms to right side, we get 3B minus 4A. Okay, next C is equal to 3. What is the B matrix? 2 3 4 5 minus 4. A matrix is 1 2 3 4. Then multiply. C, if you multiplying any real number with matrix, this element should be multiplied to each element. Okay, if you multiply these element to each element, you get 3 2s are 6, 3 3s are 9, 3 4s are 12, 5 3s are 15. Okay, you multiply these element with each element. Next, again similarly multiply 4 with each element, you get 4, 4 2s are 8, 12, 4 4s are 16. Then see 6, then take 6 minus 4. Okay, 6 minus 4, then 9 minus 8, 12 minus 12, 15 minus 16. Then finally you get 6 minus 4 2, 9 minus 8 is 1, this is 0, this is 15 minus 16 minus 1. Then this is B option, 2 1 0 minus 1. Okay, next 8th question is what? 8th question is given, if the matrix has 16 elements, then a possible dimension it can have. Okay, see, the matrix is 13 elements. Okay, see, I will give one simple example. If the if you consider 2 by 2 matrix, okay, how many position it has? 4 positions. Okay, 4 elements, right? This and this, these are 4 elements we can fill, right? How many matrices we can form means, okay, how many elements are present in this? 4 elements. That means, suppose similarly, if you multiply number of rows into number of columns, okay, that is equal to number of elements in matrix. Okay, see, this 2 into 2, if you multiply 2 into 2, you get 4. That means 4 elements present in 2 by 2 matrix. Similarly, 13 elements. Okay, if the matrix contains 13 elements, that means if you multiply number of rows and number of columns, it should be equal to 13, right? What are the possible ways? 1 into 13, okay, otherwise 13 into 1. Okay, only two possibilities, right? Only two ways we can take, 1 by 13 or 13 by 1. Only two matrices gives us 13 elements. Okay, if you multiply number of rows and number of columns, okay, that should be equal to number of elements in the matrix. That means which option? 1. That means A option is the correct one. Only 1 by 13 and 13 by 1. It is same way. 12 elements. If the matrix contains 12 elements, what are the possible ways? One is 1 into 12, okay, and 12 into 1, again 2 into 6, or 6 into 2. If you multiply number of rows, number of columns, that should be equal to number of elements of that matrix. Okay, 6 into 2, again 4 into 3, 3 into 4. Okay, then is there any other way? And another possibility, only 1 by 12, 12 by 1, 2 by 6, 6 by 2, or 4 by 3, or 3 by 4. That means option A is the correct option. Only option 9 is the correct option. Then how many matrices of the order 2 by 3 are possible with each entry 0 or 1? Okay, see, 2 by 3 matrix. 2 by 3 matrix means 2 rows, 3 columns. 2 rows, okay, 3 columns, right? These are the position, these are the elements. Okay, that means each position should be 0 or 1. 0 or 1, 0 or 1, 0 or 1, 0 or 1, 0 or 1. That means for each position how many possibilities? 2 possibilities. It is also 2 possibilities. It is also 2. It is also 2. It is also 2. It is also 2. That means if you multiply all these possibilities, 2 into 2 into 2 into 2 into 2, how many? 1 2 3 4 5 6. 1 2 3 4 5 6. That means 2 raised to power of 6. Okay, these are the possible ways. 2 raised to power of 6. That means option C is the correct option.